All right, welcome to The Explainer. Today, we're heading to the most chaotic, most violent place in our entire galaxy. Its very heart. It's a place we thought we kind of understood until a tiny persistent whisper from the edge of a black hole changed absolutely everything. So, we've known for a long time that there's a monster lurking right at the center of the Milky Way, a supermassive black hole. But it turns out, it's not alone. Something tiny, rhythmic, and incredibly precise is hiding in its shadow. And finding it has just solved a major cosmic mystery. Okay, picture this. Astronomers are sifting through all this data from the Green Bank telescope, and then they find it. A faint but unbelievably persistent pulse. A cosmic heartbeat from the very edge of Sagittarius A star, our galaxy's 4 million solar mass black hole. And let me tell you, this tiny signal is a huge game changer. So what in the world could send a signal that precise from a place that chaotic? Well, the culprit is one of the strangest and honestly most wonderful objects in the universe, a celestial lighthouse we call a pulsar. So yeah, meet the pulsar. It's basically the hyper-dense spinning corpse of a giant star. Get this, a single teaspoon of this stuff would weigh billions of tons. We're talking about one of the most extreme forms of matter in the entire universe. A pulsar is born out of one of the most violent events imaginable, a supernova. You have this massive star, it dies, its core collapses, and it crushes matter itself. What's left behind is this super dense, spinning remnant that blasts these powerful beams of energy out into space. And this process shows off a fundamental law of physics perfectly. You know how figure skaters spins faster when they pull their arms in? It's that exact same principle, the conservation of angular momentum. It forces that collapsing star to spin at just incredible speeds. What was once a slow rotation becomes this frantic, high-speed blur. So just how fast are we talking about here? Well, the signal that astronomers found repeats every 8.19 times milliseconds pulse. That's the time between each pulse. This thing isn't just any old pulsar. It's what we call a millisecond pulsar, one of the fastest spinning objects we know of. Let that sink in for a second. It's spinning more than 120 times every single second. And the amazing part is, these things are unbelievably stable. Their timing is so precise, it can actually rival the accuracy of atomic clocks we have here on Earth. They really are the universe's most perfect clocks. Okay, but here's where it gets really interesting. This discovery isn't just about finding a new pulsar. It's about solving a cosmic cold case that's been bugging astronomers for years, the mystery of the missing pulsars. You see, for decades, scientists have been stumped. The whole area around our supermassive black hole, Sagittarius A star, it should be like a pulsar graveyard, just littered with the remains of massive stars. Our theories predicted there should be hundreds of them there. But when we looked, we found pretty much nothing. It was a genuine puzzle. And here's why. The heart of the Milky Way is basically a cosmic storm. It's shrouded in this thick dust, and all the space between us and it is this roiling sea of turbulent plasma. All that chaos scatters and smears out the sharp, precise pulses from a pulsar, which makes them almost impossible for us to detect from Earth. So the really crucial point here isn't just that we finally found one, it's where we found it. Its location, right on the doorstep of a supermassive black hole, transforms that whole region into a one-of-a-kind laboratory for testing the fundamental laws of physics. This find lets us test Einstein's theory of gravity in an environment that is way more extreme than anything we've ever had access to before. I mean, we've tested it in the relatively weak gravity of our solar system, sure, but this is the ultimate stress test. We're getting to watch an object in the warped, twisted space-time right at the very edge of a black hole. And because this pulsar is such a perfect clock, we can look for these tiny millionth of a second variations in its signal. These little shifts can tell us if time itself is slowing down, or if space-time is literally being dragged around by the black hole's spin and all these other incredible effects that Einstein predicted. In effect, what we've done is place the universe's most precise metronome inside our physics lab. And now, we can watch the direct impact of warped space-time on its ticking. This isn't some indirect measurement. We are literally listening to the rhythm of space-time itself. And that brings us to the biggest takeaway of all. This isn't just about confirming what we think we already know. It's about pushing the absolute boundaries of physics. You see, while Einstein's theory of general relativity is brilliant, we know it's not the whole story. It just doesn't work with quantum mechanics. Physicists believe that in the most extreme places in the universe, like the edge of a black hole, we might finally see tiny cracks in Einstein's theory, the kind of cracks that could point the way to a new, more complete understanding of gravity. We can even test this fundamental and kind of weirdly named idea about black holes called the no-hair theorem. It's a quirky name for a simple idea, that black holes are incredibly simple objects with no distinguishing features or hair. But are they really? Precise measurements of this pulsar's orbit could reveal unexpected wobbles, suggesting that black holes might be a lot more complex than we ever imagined. I think this quote from the research team just captures the significance of this discovery perfectly. That tiny rhythmic signal traveling 26,000 years to reach us from the edge of an abyss, it's a message coming directly from the fabric of the universe itself. So as scientists keep listening to this incredible cosmic clock, that's the ultimate question, isn't it? It's a question that's going to drive one of the most exciting quests in modern astronomy. Will Einstein's theory hold up yet again? Or will this tiny pulse from the heart of our galaxy lead us to a whole new understanding of the universe? The answer is out there, ticking 120 times per second, at the edge of infinity.